All right, folks, we are going to take a look at plate boundaries today. The word boundary means where two things come together. And during class, we'll take a look at some of these other resources, what the world looks like without water, or things like that. In the meantime, let's do a quick review. Something that we already know is that the continents haven't always been here. This is what the map looks like today. But 100 million years ago, it looked more like this. And 150 million years ago, they looked more like this. And we haven't talked about Labrasia or Gondwana, that those happened right after Pangea. Pangea wasn't even the first because there was still stuff going on even before Pangea. But Pangea was when all of the continents that we know today were already formed, and they were all just one big piece. Now, over millions of years, the continents started to split up and drift away from each other in different directions. Now, we know this. Continental drift has been proven because we have these matching fossil records. The same fossils in South America and Africa match up perfectly because they used to be connected. And we also know that because of the seafloor spreading. If you go to the bottom of the Atlantic, you can see that the Atlantic Ocean is actually getting bigger because its seafloor, the bottom of the ocean is spreading out. We also checked the rocks and mountains in North America and Europe and saw that they matched up. And there's also been some climate change evidence in places like Antarctica that used to be tropical areas, suggesting that they were probably not always at the bottom of the world. So today we're going to talk about plate tectonics. Plate tectonics is the idea that the lithosphere, or the crust, is broken up into several different pieces called tectonic plates. So this map shows all the different tectonic plates, like the big ones. Those pieces of crust, or I'm sorry, those pieces of the lithosphere, are always moving around because underneath them is all of this convection. As a review, the word lithosphere is the crust and the top part of the mantle, the solid part. The top part of the mantle, even though it's technically semi-liquid, it acts a lot like a solid because it flows so slow that some scientists put it in the lithosphere. The asthenosphere is wherever you're seeing convection in the mantle. So let's take a look. Why are these plates moving? Here you've got your lithosphere, and underneath it you've got your asthenosphere where convection happens. Well, I want you to take a look and imagine what it would be like if you were floating, if you're on something solid, but you're floating on an ocean of liquid that was moving like this. As it moves up, it may push you in that direction. And that's what happens to all of these plates. They're getting pushed all around the globe. And that's because the convection currents in the asthenosphere are making it happen. All right, so pause the video if you need to, go back if you need to. The front of your page should be done. The front of page 4 should be finished. Let's move on to the back side and some ideas back there. So if all of these plates of the crust are moving around and bumping into each other and all of that, they must all have these boundaries. There's a space between all of them. And where two plates come together, we call that a plate boundary. For instance, the African plate and the South American plate, you can see that there's a spot right in the middle where they come together, and that's called a plate boundary. If you think about it, there's 3 different types, and in the next video, we'll talk about what the 3 types of plate boundary are.